Hey guys, in this video we will be seeing how to set up the food catalog listing microservice. In the previous video we have seen how to configure the restaurant listing microservice. Let's consider a Swiggy Zomato application, okay? In the first page, main page, you see all the restaurant list. On clicking that particular restaurant list, we get inside the restaurant. What we see is all the food item catalog that particular restaurant offers to us. Also, not only that, they also offer restaurant details like where this restaurant is present, the address of the restaurant, details of the restaurant, it is veg, pure veg, non-veg, mix of both. So all these details are also available on the food catalog listing page. In the previous video, what we have done is how to show all the list of restaurants. In this particular microservice, we will cater to a single responsibility to show all the food items of that restaurant, also the details of that restaurant. So food catalog microservice is responsible to showcase two things. All the list of food items of that particular restaurant. So what we need to pass from there is the restaurant ID. And from here microservice, we will fetch only those food items that is corresponding to that particular restaurant ID. Also, not only that, we need to hit the restaurant listing microservice where we have saved all the restaurant details. And the mix of both responses will become the total response of food catalog microservice, which will be responsible to showcase the web page where when you hit a particular link of the restaurant, complete details of restaurant and complete food menu of that restaurant comes as a front end or UI to us. So on front end page where all restaurants were listed, when we select one restaurant, then all its menu is shown, but also the restaurant details, its addresses and everything will be shown on the page. Again, the tech stack will be the same as we have used in the restaurant listing microservice. We'll be using the microservice architecture with REST endpoints, Java 11. Again, the data source will be MySQL relational database and not MongoDB. We're going to use MongoDB in order service. We'll see why. Then Spring Boot, Lombok, Eureka Client and WebStruts. Similar things, very similar to what we have done in restaurant listing microservice. I have explained all of these in very detail in the previous video. Not going to cover everything in very detail in this particular video. So let's get started and start configuring a Spring Boot application, adding the starting dependencies, configuring the properties file and adding the MVC layers. So let's go to Spring Initializer and create such project. Again, the language will be Java, build tool will be Maven. 2.7.12 will be the Spring Boot version. The group name can be com.codedecode. Artifact name can be food catalog. Name can be food catalog microservice. Package name will be group name.artifact name. So com, code decode, food catalog. Java 11 version we can use. Now for the dependencies, we for sure need Lombok. We for sure need Spring Web to make it as a web application. JPA, that is a ORM framework to connect to database, but we also need MySQL connector to have a real drivers in place to have connection to MySQL DB. We also need Eureka Client to make it as a Eureka Client and register to Eureka Server. So when we will be running this, first Eureka Server has to be running up and running for us. Also what we need is Mapstrut, which we do not get here as a recommendation by Spring Initializer. So we'll be adding it later when we have our application imported in IntelliJ. So let's generate the project and have this food catalog microservice imported in IntelliJ. So the sync is done for food catalog service. We have food catalog microservice application here. Let's see in the pom.xml if we have everything that we require. We have data JPA as ORM framework, Spring Web to make it the web application, Eureka Client to register to Eureka Server, connector to connect to DB, Lombok. Now we need is a Mapstrut dependency. So let's add the Mapstrut dependency and plugin with Lombok to convert our entities to DTOs and vice versa. So here after Lombok, I'm adding the dependency for Mapstrut 1.4.2 final. Also, I need to add plugins here. So just below the plugin for Spring Boot Maven plugin, we are going to use Maven compiler plugin, where we will be adding two annotation processor paths, one for Lombok, one for Mapstrut processor. This will be required when we want to convert our entities to DTOs and vice versa. Let's update the Maven and let's update the catalog microservice. With this in place, let's quickly start this creating structure of this particular application with the web layers like controller, service, repository, entity, DTO, like we have done in the previous video also for restaurant listing service, and also a mapper for conversion. So let's start doing that. This is our controller package. This is service package. This is repository package. This is entity package. Then we have DTO package. And at the end we have mapper package, where we will be having the mappers. Now let's start creating the entity first. That will be a new Java class called as food item. This will be stored in the food catalog applications database. Now this food item is going to be an entity. I'm lazy enough, so I'm putting Lombok data, prevent me writing getters and setters, @ no argument constructor and all argument constructor. Now what does the food item contains? When you go inside a particular restaurant, what do you see for the food item? You see food item name, food item ID, food item description, how it is, in which gravy it is prepared. Then you see its quantity, how much you can choose. Like you want 2 chapatis, 3 chapatis. Then you can also have it is vegetarian or non-vegetarian food item. Then you also see its price, how much does it cost to you. And a very important attribute, to which particular restaurant ID does this particular food item belongs to. It's not always that all food items will belong to each and every restaurant. Some restaurant might provide you pizza as food item, some may not. So let's start creating the food item. So I'll have food item ID, item name, its description, its food item is vegetarian or a non-vegetarian item, its price, and also that food item belonging to which restaurant ID. And lastly, what I need is quantity. How much quantity of that food item you are selecting to add it in your cart. I have to initialize it with 0 because initially when you get into the restaurant, all the items that you are selecting is with 0. Then you click on a drop down to add more items to the cart. So initially I want its value to always be 0. So this is how at the column, giving a column definition to make it default as 0 here. With this in place, food item is done. Also remember that you can think that I can make pizza as one item ID and make it as primary key with ID and restaurant ID common, but that's not gonna be the case because there can be a chance that pizza is for one restaurant ID 1 may have a different price and the same pizza for different ID can have different price. So you might not have single pizza in the whole database. You can have multiple pizza entries with different prices, different boolean values, descriptions, different item descriptions. So not always have pizza as a unique item name in the database. You will always have multiple pizzas in the database. Their IDs will be unique rather. So our entity is ready. So let's go and create a Java class, that is food catalog page. This page is not going to be an entity. I'm just going to put @data, @no argument constructor and @all argument constructor. This page is the one who will be responsible for showing all the food items list and restaurant details on the front end. So I need 2 things. First, list of food items, food item list, and secondly we need restaurant details. So first we need to create a restaurant detail also, and this will be completely same as what we have created in the restaurant listing. So I'm going to copy paste from there. So open project, restaurant listing service. Here we had restaurant entity. Here it was entity because it was saved in database. There it is not going to be an entity because we are not saving this restaurant in our food catalog microservice database. Rather, we are just going to hit this microservice and fetch this particular response from restaurant listing service. Hence, this is not going to be an entity there. It is going to be a DTO there because it is just a data transfer object that happens from restaurant microservice to food catalog microservice. So I'm just going to take these parameters so that whenever I get a response, JSON response, I should be able to map it to a particular POJO or DTO. So I'm just going to copy this and save it in my restaurant POJO. I'm going to create new class restaurant, which is not going to be any entity or argument constructor, no argument constructor, and data, and only the fields, that is ID, name, address, city, and restaurant description. So in the catalog page, we also show them this restaurant details. So that is why we'll be needing 2 things. The list of food items, which is entity for us here, and the restaurant details, which is a DTO here. So together they form the whole catalog page. When you click on a particular restaurant, you will see all these 2 details on your page. So that will be coming from this particular DTO, data transfer object. But only what we will be saving in the database is just food items with their restaurant ID mapping, just that. Whenever DTO and entities are done, now we'll be creating a repository. Repository will only be created for food item because nothing else we are storing in our database. So we'll be creating a food item repository, but this is going to be an interface for us. And this is going to extend JPA repository, which is going to have a generic type having the first argument as entity, which is food item, and its primary key, which is integer, that is food item ID. Once done, we can mark it as @repository and our repository is ready. Now in the service, I'll be auto-wiring this particular repository. So first let's create the service, food item service, or we can say this service is also going to return us multiple food catalog page business logics. So I can make this as food catalog service. This is going to be @service for us, and it's going to auto-wire repository. Now I'm going to auto-wire this service in controller. So I'm going to create a new class, food catalog controller, and I'm going to map it as REST controller and request mapping, which is having the base URL for this food catalog microservice, that is food catalog. It's going to auto-wire our service layer. Also in the DTO, we will be needing a food item DTO. So in the DTO, I'm going to create a new class, food item DTO, which is going to have all these variables and Lombok pointer. So @data, no argument constructor, and all argument constructor. That's it. So our DTOs are ready, our entities are ready, controller and every layer is ready. Now we need to create a mapper. So I'll be creating a new mapper, which is going to be an interface named as food item mapper, which is going to be annotated with @mapper. Now again, the same thing that we have done in the previous video. We need an instance to access methods in the food item mapper. So first, for the same food item mapper, I'm going to create an instance of this. So mappers.get mapper for food item mapper dot class. So our instance is ready. Let's create two methods, one to convert your food item DTO to entity and one for food item entity conversion to food item DTO. Next, to map food item to food item DTO. So here we are mapping food items to food item DTO. So we are passing food item. So our methods are also ready now in the mapper. Now in the controller, we need two REST endpoints. What are those two endpoints? First endpoint is to add the food items in the database. So this is going to be much more local. In the backend, we are going to hit this particular REST endpoint to add food items in the database with the restaurant ID. And second REST endpoint will be to fetch all the restaurant details and food item list when a particular restaurant ID is given to you. So let's get started and create those two REST endpoints. First, we'll be creating a local endpoint to add food items in food item database. It's going to be the post mapping add food item. And we will show the client the food item DTO. In the request body, we will be getting the food item DTO and we will be calling the service method to first convert this item DTO to food item entity and save it in DB and return the DTO format of that. So food catalog service dot add food item and pass your food item DTO. Again, what you will be receiving is food item DTO saved, food item saved, and we are going to return new response entity where the food item is saved, comma, status as created, because we have created one food item in DB. Now I'm going to create this food item in service layer. Now first of all, I need to add this to database. So food item repository dot save. But what we can save is entity and not DTO. But what we have is DTO. So what we need here is a mapper. So food item mapper to instance of food item mapper that we have created. And what we need to do is to map DTO to food item. And already we have the food item DTO. So what it will return is, this will return you a food item. And food item, since it is an entity, it is capable enough to be saved in the database. And when it is saved, it will be returned also. So what it will be returning is a food item. Food item saved in DB. Now you have an entity which is saved in DB. What you need to return is food item DTO conversion of this entity. So again, food mapper.instance dot map this particular entity to food item DTO. So this is your entity and what you will get in return is a DTO. If you can see, what you will get is a return is a food item DTO. So this item DTO you can return in your controller layer. So here you can see you get a DTO and you can easily return it in the controller layer. Now let's try running this. Are we able to run this particular REST endpoint successfully and add an item in the database? But before that, we need to configure our connection to database. Also, we need to configure the port because we have decided to have the 909X port series, server port series. we will be needing to configure the server port. Then we'll be needing to make this application as a Eureka client and register itself to Eureka server. Also, we need to configure the application name, which will be registered as an instance in Eureka server in the applications part. And at the last, we need to configure the data source. So all those 4 things we need to do. I prefer using application.yaml file. So I'm going to create application.yaml file here. And here let's start configuring all the 4 things. The server port, the Eureka client, the application name, and the data source URL. So here I have configured server port as 9092. I have also configured Eureka client to point to localhost as of now because I'm running everything in local and not in Docker. We'll create another profiling with dev environment where we are going to have the Dockerized address of Eureka once we deploy it on Docker. Apart from that, I've also configured the food catalog service, which is the name of the application. Also, I have configured the data source URL to our localhost 3306. I need to create this DB in my SQL Yog. I cannot see this DB here, so I'll be creating a DB. So create database food catalog DB and run. So 1 row is affected. Here when you refresh, you can see the food catalog DB present here where the tables are empty. Now since you have your database in place, you can connect to it. This is the driver name and everything I've explained in the previous video. I'm not going to go through each and everything here in this video. Configurations is ready. Let's quickly start the Eureka server first. So this is our Eureka server. Let's run this application. So Eureka has started for us. Now let's try running this food catalog microservice. So if you can see here, Hibernate is creating the table food item for us where we have all the fields that we have given in the entity. And also it has given a default as 0 for quantity. Also it has created a sequence table for you and it has initiated that sequence table with 1. Remember, this is a luxury to you which is given by Hibernate to create a sequence table when you want an auto-generated ID, which is not a luxury given by MongoDB to you. So since there is only one entity, still you can see 2 tables here. Let me refresh this for you. You can see 2 tables here automatically created. One is for food items, which is empty as of now, and another is a Hibernate sequence, which has initial value as 1. When it comes to MongoDB, you have to explicitly create this sequence generator table for yourself. Mongo is not going to create it for you. So when you use MySQL DB, Hibernate sequence will be a luxury that is provided by Hibernate to you automatically. It says application has started at 9092 port number. Let's see if in our Eureka server, we are able to see the food catalog service. So yes, we are able to see the food catalog service in Eureka's dashboard also. When I run both the applications together, the restaurant listing service that I have created in the previous video and food catalog service, then you can see both the applications here. We'll come back to this when we create the second REST endpoint for us. So let's try adding some items in the DB. So here in the Code Decode Udemy API collections, we have 3 collections that we have created for restaurant listing microservice. I'll be creating a new folder here for API collection for food catalog microservice. And I'm going to add a post request at localhost 9092, the base URL as food catalog, and add food item as the post mapping path to add a food item. I'm going to save this as add food item, and in the body it will be getting a JSON. So I'm trying to add one food item here, say dal fry, with item description lentils cooked with mixed spices. Vegetarian dish is true. This is a boolean field here is vegetarian. So yes, our dal fry is a vegetarian dish. Its price here. The restaurant ID for which this particular item is being added. This is very important. And the quantity initially will be 0. Even if you don't give it, it's by default 0. So let's try adding this, whether we are able to add the food item in the DB. And says 201 created where with ID 1. So here we did not pass ID, it's auto-generated with ID 1 and the Hibernate sequence would have increased the sequence now to 2. So here you can see we are able to generate the proper table, it's updated, and also in the Hibernate sequence we can see the next value is updated as 2 automatically. So our post endpoint is working perfectly fine and we are able to add the food items here. The next endpoint is a very important endpoint that will be exposed to the outside world. That will be the one that is going to be hit and it will return you 2 things, the food item list and the restaurant details. So we're going to create a get endpoint which is going to fetch all the item details and restaurant details when we are hitting it with particular restaurant ID. So let's create that REST endpoint now. So get mapping fetch restaurant and food items by ID, and we're going to pass the ID as the path parameter. What we are getting at the end is going to be the food catalog page, which is having the list of items and restaurant details. So the response entity should have this. The method name can be fetch restaurant details with food menu, and we're going to use a path variable as restaurant ID. So integer ID will be used. That's restaurant ID that we are going to fetch, on the basis of whom we are going to fetch the menu details and restaurant details. So now I'm going to call the food catalog service to fetch food catalog page details. And I'm going to pass the restaurant ID here. And at the end, what I'm going to get is the food catalog page. And I'm going to return a new response entity with that food catalog page and HTTP status as OK. A new object of it. Now let's create this fetch catalog page details method in service layer. Now here we need two things. First, we need food item list, which can come from our own DB, and the restaurant details, which will come from restaurant listing microservice that we have created in the previous video. So I'm going to create two methods. First method is going to fetch food item list on the basis of restaurant ID that we are passing. And second method to fetch restaurant details from restaurant microservice. And again, I'm going to pass the restaurant ID because on the basis of restaurant ID, we are going to fetch the restaurant details. And at the end, I'm going to create food catalog page. And I'm going to pass the return type of these two methods. That is, first we are going to get a list of food items. And from the second method, we will be getting the restaurant DTO. I'm going to pass both of them so that a combined response can be created and sent to the front-end user. So let's go ahead and create these three methods in the private methods in the service layer only. I'll always prefer to modularize your code in such a way that it is readable enough. So I want to create a food catalog page, which is a combination of two things: list of food items and restaurant details. So always modularize your code in multiple private methods so that it is more readable and you understand what each method is doing. So each method should have a single responsibility. The fetch restaurant details has a single responsibility to go and hit the microservice, get the details. The fetch food item list has single responsibility to go hit the database, get the list of food items. And the create food catalog has a single responsibility to merge two responses as one food catalog page DTO, which will be returned to front end to show everything on the page. So always modularize your code in such a way in different private methods that each method has a single responsibility principle followed. So let's go ahead and first create a method to fetch item list based on restaurant. So we have food item repository with us. The food item repository dot find by restaurant ID. And I'm going to pass the restaurant ID here. And I need to create this method in JPA repository, food item repository here, which is going to return you the list of all food items. So this method is capable enough to get the restaurant ID, pass it to find by restaurant ID method of repository and return the list of food items, all the food items which are mapped to that particular restaurant ID. The next method is fetch restaurant details from restaurant microservice with T here, I forgot that. This method is going to hit our restaurant listing microservice and fetch the restaurant details based on the restaurant ID. Now to fetch the details from another microservice, we need a REST template. So here, first in the microservice application, since it is Spring Boot application, it is @configuration automatically included in it. Hence, I can create a bean here. So public REST template, get REST template and return new REST template. But remember, we can have multiple instances of restaurant listing microservice. Suppose we have 3 instances. Now, which out of these 3 should this REST template go and hit and get our data? So it should be load balanced. Why it should be load balanced? Because there can be multiple instances of the restaurant listing microservice. Now it's the task of Eureka to find the instance which is not so busy or is available to quickly respond to your request. Go to that particular instance and fetch our restaurant details. So to make it load balanced with Eureka, who is going to do it internally, you just need one annotation load balanced, and it will be task of Eureka to give you the result quickly out of multiple instances you have in the Eureka server. So this is how I have given the bean for REST template. The only thing I need to do in my service is to auto wire this now. So like we have auto wired another beans, we need to auto wire REST template also. Now since you have created a bean here, when you auto wire this, the return type of this REST template will be a load balanced REST template here in the food catalog service. Now you have your REST template ready. The task in this method that you have to do is to return the restaurant by hitting the REST endpoint. So REST template dot in the restaurant listing microservice, what is the controller to return you the restaurant by restaurant ID? So that's fetch by ID by passing the ID, and it's a get mapping. So get for object, what it will be taking is a URL. So to create the URL, you can run this application. So currently we are making this restaurant listing microservice up and running. We know it's up and running on 9091. What we can do is we can directly hit HTTP localhost 9091 and fetch the restaurant details. But that is not the right way to do it because we are using Eureka in between. You should always use not the localhost 9091 but the name of the service. That is restaurant service that you have given here in the application.yaml. The restaurant service, that's the name. Since there can be multiple instances at different ports and different instances running, you should always use the load balanced URL format to hit the particular microservice in a microservice architecture. You can do it localhost 9091, but that will not fulfill your request when you have load balanced multiple instances running on Eureka on cloud. So do it in a better way. Do it in the load balanced way. So create a URL in the load balanced way. The URL can be http:// rather than localhost 9091. You can directly use the microservice name, and it will be the task of Eureka to understand this. What does that Eureka service means? By using the dashboard, you can also see this restaurant service can be easily verified as localhost 9091, and then you can go ahead and give your URL. So the URL to hit is fetch by ID and pass the ID. Fetch by ID and pass the ID. So what is the ID? Restaurant ID that we already have in the method. And the second parameter that get for object takes is the response type. So you will get a response, but you need to map that response to your own Pojo. So we have already created one Pojo or DTO, that is restaurant here in the DTO folder. So whatever response you get from the restaurant listing microservice will be mapped to restaurant DTO in our application. So this is how you hit a load balanced microservice registered to Eureka and leave it to Eureka, which can automatically resolve it to localhost 9091 when you use restaurant service as your URL. Now remember, this is a very bad habit to use the URL directly here. What you can do is, you can rather using the hard coding here, you can do it in the application.yaml file or use the config server, which we are going to do in the course later on, and add this URL to that properties file so that whenever the URL changes or some nitpicker changes here, you don't have to change your source code. The return type for get for object is going to be the generic type T, whose response type you are giving here. So the response type that we have given is restaurant.class. So the return type will also be the restaurant. Now you have your restaurant in place. What you need to do is just return this. So rather than doing it here, I can directly put return. Now your two methods are ready. One is going to fetch all the restaurant items list based on the restaurant ID. One is going to fetch all the restaurant details based on restaurant ID. Now you need to create a combined object for both of them. So food item catalog page equals to new food item catalog page. Now here the no argument constructor comes into picture. If you would have just overridden the all argument constructor and not used the no argument constructor, you would not have been able to use this no parameterized constructor. So that's why I say whenever you override the all argument constructor, always override no argument constructor also. Now in the food catalog page, I have two fields. So I can set the food item list that I get from here, and also I can set the food catalog page dot set restaurant, the details that I get from the second method. And the last thing, we need to return this. So return the food catalog page. Now you can happily return what you get from this create food catalog page, because it has both the things in place, the food item list and the restaurant details. One coming from your own database, one coming from hitting the microservice. Once this is done, let's quickly test this. In the catalog, you can see that food catalog page is coming and you can give it as a response. So let's quickly check whether giving a restaurant ID, we are able to fetch the proper details or not. Now to fetch the food catalog page details, I'll be using the get request with http://localhost 9092 food catalog. And what's the URL for this? Fetch restaurant and this by order ID and ID as 1. So our Eureka server is up. I have checked this. We have food catalog service up. We have restaurant service up. Both of the applications are up and running at 9091 and 9092 respectively. One mistake that we have done here is we are using the path variable. Remember that initially we were using ID here and we were taking in restaurant ID, which is not mapped. It says it requires a URL template variable restaurant ID to be mapped somewhere, right? So it is not mapped. ID is not getting mapped with restaurant ID. So either you pass ID here or you pass the restaurant ID here. So I'll be passing the restaurant ID here for the better understanding. And let's restart the application. Application started. Let's try hitting it with 1 now. And yes, we are able to get the restaurant ID 1 here with the path variable. Let's try hitting our own database and fetch the restaurant item list for that particular restaurant ID 1. So here we are able to fetch the item list by restaurant ID. This is the select query that is running where restaurant ID is 1. And when we evaluate this, we are able to get the food item. So here we are able to fetch the food item from the repository. This is for the restaurant ID 1. We are able to fetch the item dal fry. And is everything that we have set. So this is working fine. We are able to fetch it from our own DB. Now let's try to fetch the restaurant details from the restaurant listing microservice. So we'll be hitting the restaurant service. So this is the URL to be resolved by Eureka /restaurant. So here in the restaurant listing service, this is the restaurant /fetch by ID. So restaurant /fetch by ID and restaurant ID as 1. Let's try hitting it and see we have the debugger coming in the restaurant listing microservice. Let's fetch the data from here. So you can see that we have both the things in place. We have restaurant details and the food item details both present in our response now. The only thing remaining is to create the food catalog page now. So we have the food items with us. We have the restaurant with us. We can create the DTO and see we have a proper response in place with the food item list. We have the item list present. You can see this is the list of items. And you can see you have restaurant details also. So when you are going to create the UI page, you can show the restaurant details also, and also you can show the list of items in the tabular or some bullet format also with all these details here. So that's how our both the REST endpoints are working perfectly fine. We are able to add the items. Also, we are able to get the item details also with the restaurant details by hitting the restaurant listing microservice. So that was all about how to configure the food catalog microservice.